In today's lesson, we're going to take a look at solving multiple step equations. This is really just an extension of what we did yesterday, but what if we have to do more than just one step, adding something to one side, dividing something from one side? What if there's more for us to do? And then how can we check the reasonableness? And I really want to emphasize this because I want you walking away and seeing in this class, you can walk away from most of the problems we do knowing for sure that you got it right. And that's going to be really helpful for us. All right, so ultimately, to solve multi-step equations, we're going to use the inverse operations to isolate the variable. All that means is, inverse operation, if you see a plus sign, you do subtraction. If you see multiplication, you do division, all right, to get the variable by itself. So down below, we have a problem here. And again, it's a word problem, so we want to start. I mentioned this before. We're going to start by reading the question. After how many years is the tree 24 feet tall? So the question even has something in there. They want to know how many years. So X is the number of years you can see here. After how many years is the tree 24 feet? Like that's what we're trying to figure out. Okay. But they give us this other equation to help us out. And they tell us kind of this idea. It says the height of the tree after X years is this. And so this I'm trying to find this X, but it's hidden, it's masked in this formula. Meaning for every year that passes, you add 1.5 feet. Okay, that's what this says. For every year that passes, that's what X is. It grows by 1.5 feet and it starts at 15. So instead of putting X here, we're going to put this entire thing. How long will it take it to get to 24 feet if you end up with this? And I want to explain this. I want to make sure we see this. This is telling you how tall it is when it starts. And then this is telling you how much it grows every year. Okay, those are going to become really important to us later as the year goes on. So notice in this one, I have to do two things. I have to do more than just one. And actually, let me do this really quick. Let me erase that. Let me write that in black for us, and we can kind of write over this in red. So yeah, 1.5x plus 15 equals 24. If the tree grows at this rate, how long will it take to get 24? Well, what we're going to do is inverse operations. Now, PEMDAS, if you think of PEMDAS, we normally would do multiplication, division before addition, subtraction. But because we're trying to solve for a variable, in this case, our variable is right here. Okay, we're going to do the inverse operation, so we're going to kind of do things backwards. So the first thing I'm going to do here is subtract 15. Remember we saw yesterday, if I do something to one side of an equation, I can do it to the other side. And the reason we would do this is we're trying to isolate or get the variable all by itself. So these are going to go away. They cancel out. By go away, I never mean they magically disappear, but 15 minus 15 is 0. Okay, so I end up with this 1.5x equal to 24 minus 15 is 9. And then I still trying to isolate this variable can divide because these are being multiplied together by 1.5. All right? And I'm going to get 6. Okay, x equals 6. In context, that tells me it's going to take 6 years for this tree to grow to be 24 feet tall. Okay? All right, notice again, I want to emphasize this. It's already 15 feet tall when it starts, and it increases by a certain amount. So 6 years. The multi-step part is the fact that we had to do two things, the red stuff and the blue stuff. Okay? Now, the reasonableness, it says check the reasonableness. We'll take a look at on other problems. We're going to leave this one where it is. We'll look at kind of what does that look like on something like this. Okay? So on this one, we're going to do several things. So the first thing we're going to do is note where our plus or equal sign is. We want to keep track of that all the time. Okay? And so everything we do, if I move something over from the left side of the yellow line to the right side, I have to do an inverse operation. But I also can combine like terms on one side. Since I'm not moving anything over to this side, I could put these together simply by doing whatever mathematical operation it says. This is 8x minus 6x. So I'm going to rewrite this equation as 2x, and we'll do everything else in black here, minus 25 equals negative 35. All right. To evaluate this, okay, we kind of did one thing. Now what I'm going to do is I'm going to move the 25. I'm trying to isolate my variable, so I'm going to start moving things over. And as I said, we start with addition, subtraction. So I add 25 to both sides. These will cancel out. And I have 2x equals negative 10. Be careful on this step that your math is working out carefully. It's a negative plus a positive, so I'm going to stay negative because the bigger number is negative. Get that? And then I'm going to divide both sides by 2. So x equals negative 5. Now, when it says check the reasonableness, I'm going to back up to my original equation. And this is one of the things you can do. To check, you're going to plug in. And all that means is I take 8 times x minus 6 times x minus 25 equals negative 35. And anywhere I saw an x, notice I left them blank, I'm going to put this number. And your goal is simply to see, does that make this statement true? We're going to put a question mark here, are these two sides equal? We can kind of keep track of it that way. So on the right side, I don't have to do anything. But on this side, there's some math to do. And I'm going to solve this. I've got negative 40 plus 30 minus 25. Okay? And I'm asking, is that equal to negative 35? Well, negative 10 minus 25 is negative 35, and that equals negative 35. Okay? So anywhere it asks you to check, all they're asking you to do is solve this way and take your answer and plug it back in. And here's the nice thing. Unless you made a mistake here and a mistake here, and magically, not magically, but they happen to cancel each other out, then what will happen is, if I did this wrong and I got some other number here, when I plug it in here, they won't be equal. And if my work here is correct, then I'm going to know whether or not I got it right. And it's just a nice thing if you ever have time, which again, during this context, I would say you guys have a little more time to work through some of these and double check your answers, especially on a quiz or a test. You could double check your answers, make sure you got it right, make sure this worked. If you didn't get the right answer, well, double check your math. And if this is all correct, your math is correct here, and you're sure, you can go back here and say, okay, I must have done something wrong here. All right? Don't erase everything right away. Okay? Go back and look at your work, find the mistake, and that'll help you out. All right? So I've got a couple tries, and I want you to take your time to solve these. And I want you to check your answers. So what I'm not going to do this time is put the answers up, okay? At least not right away. I want you to look through these for yourself, and I want you to check and be convinced whether or not you got the answers right. All right. Side note, if you didn't get them right and you can't figure out why, don't hesitate to ask, right? I want to help you out. On these, there's just an extra step on these, and I wanted to show you, okay? So first off, I can do what I did before, and I can subtract 4 for both sides. Okay? So I end up with 2 times 1 minus 5x equals, keeping track of that equal sign all the way down, equals negative 12. Okay? And notice what I did is I moved this 4 over. I dealt with my addition subtraction first. And now I've got this. Now there's two ways to approach this. One way is I can choose to do the distributive property, which is what I'm going to do, or I could do something else on that side, and I'll show you that. So distributive property. Now I've got 2 minus 10x equals negative 12. And then I want to isolate my variable, so I'm going to move my 2 over. Okay. Negative 10x equals negative 14. And then I'm going to divide by negative 10. X equals 14 divided by 10. They're both negative, so you get a positive, which is the same as 7 over 5 which is the same as 0.3. I lied, not 0.3. Sorry. Undo. 1.4. My apologies. Okay? So that's one way to do this. The second way is going to look the same. I'm going to start with that very first step. I subtract 4 from both sides. But what you can do is something different. I just like to throw this out there for some people because it's helpful for them to see. Now, this doesn't mean everything's going to be shorter, but it does make your numbers smaller a little faster, which is nice. Right now, I do have this variable is in parentheses and is being multiplied by 2. So instead of doing the distributive property, you can do division. These will cancel out. 2 divided by 2 is 1. And I get 1 minus 5x equals negative 6. And then I can subtract 1 from both sides. And you get negative 5x equals negative 7. And divide by negative 5. And notice that will give you automatically this 7 divided by 5 answer over here. So what it does is it simplifies, or if you think of simplification on this step, it reduces, if you've heard it said that way, your fraction a little faster. I tend to like that because I know you guys are super smart. Sometimes I sit there, and the larger my numbers get, I know the harder it's going to be for me to think through it and do it in my head. Again, this is not too crazy, 14, okay? But maybe my numbers got really big. Instead of making them smaller and more manageable just to deal with functionally. All right. Again, this one, we're going to see a lot of word problems like this, so we're going to try to think through this. Notice on this one, it says, use the table to find, here's the question, find the number of miles X we need to run on Friday so that the mean number of miles per day is 1.5. Okay, so here's the deal. First off, this one's tricky because they talk about mean, and I don't know if we know what mean means. Okay, the mean is the average, which means adding those all up. If I took 2, what we did on Monday, and 0 Tuesday, and 1.5, and 0, and X, Monday, Tuesday, Wednesday, Thursday, Friday, and you divide that by the number of days. Every day you did something, okay, you add together and you divide it by the number of days. That's how you find the average. And they say they want that total, the total mean, to be 1.5. Okay, this is kind of the equation. They want us to find out how far in order to get that. Notice we ran more than the average on the first day, but we didn't run some on these other days. So we might have to have a big run on Friday to kind of match that up. So on this one, what I'm going to do is first multiply by 5. All of this stuff is in parentheses. It's protected. I'm going to multiply by 5 to cancel out my denominator. And again, they don't magically disappear. 5 divided by 5 is 1. 1 times all this stuff, is 1 times all this stuff up here is all this stuff. All right? So I multiply by 5. Okay. On this side, I'm going to get 7.5. And then on the other side, what I am going to do, I'm going to do this right now. I don't want to lose anyone. I'm going to take all this stuff and I'm going to combine my like terms. Really what I'm combining is all the numbers, 2, 0, 1.5, and 0, which is 3.5 plus x. Okay? Then what I'm going to do is I'm going to subtract 3.5. And that will tell me that on the last day I need to have a nice 4-mile run for my average to be 1.5 per day. Okay? So you're setting up equations. Make sure you're looking in your book for these pictures on the side. They're going to provide you with a lot of good information in order to solve the problems. Sometimes all the words don't help. They help, but you also need the picture. So make sure you're paying attention to that. All right. I do have some other U-tries here. I am going to go through these ones with you, or at least I'll put the answers up. And then at the end here, I'm also going to put up the answers to the previous ones. So you can kind of check all your answers now at the end of this video that you've thought through it a little bit. All right, here's the first set of you tries. You can see the answers, and I tried to write the word carefully, and I tried to use colors to help you see the differences here and there. Make sure you look at those carefully. Again, if you have questions, if you didn't get them right, I would say don't hesitate to reach out to me, and I want to walk through them with you. On the other ones at the end here, I'll kind of try to make this a little bit bigger because there's a lot up here. You can take a look at these close. I want to mention this one really quick on this first one. I did do the distributive property first. Okay, notice I didn't move my 5x to the other side because I'm trying to keep my variables together. Please make sure you're always considering our goal is to keep our variables together, move the numbers to one side, the variables to the other. All right, this is a -1 in case that looks like a 7. I apologize for that, -1. And then the last one. All right, hopefully that's helpful to get the ball rolling. Don't hesitate again to reach out, and if you have questions on the homework, you could do the same.